Hi, I'm Shaluda Mija with 3M Electronic Solutions Division. I'm here with Mark Latang, our Applications Engineer, and we're here in a test lab at the 3M Austin Center in Austin, Texas. Today we're going to be looking at the new 3M twinaxial cable, and we're going to be comparing it to some conventional cables out there on the market. This is one of them. And what we're going to be doing is we're going to look at the mechanical performance and the benefits of the 3M twinaxial cable. We're also going to be looking at a lot of electrical performance data. So we're going to cover insertion loss, impedance, skew, eye patterns, and EMI today. I'm looking at these cables just right off the back here, and I see a pretty notable difference in terms of the bulk. This is quite a bit, more lightweight. Right. It's much thinner. It's definitely more flexible. So, question for you, Mark: are these really apples to apples? Can we compare them apples to apples?
Yeah, they are. These are both 1 meter long internal mini SAS cables, so they both have 8 differential pairs, 4 full duplex lanes. Let me give you some numbers in terms of some of the mechanical properties here. Our assembly here is 1.7 millimeters thick.
Okay.
If you measure this conventional cable assembly, between 7 and 9 millimeters, depending on where you measure it. So this is less than a quarter of the thickness of that.
Okay, and so when you look at this cable, you see a very thin profile. I would imagine that's very beneficial.
Yeah, this is something we've heard from some of the thermal management engineers that we've talked to, is the ability to fold it in a way where you can present a thin profile to the cooling airflow in a server. Significant benefit. And then some of the mechanical engineers at these same customers get very excited about the fact that we can fold, they can do folds like this, tight 180-degree folds, 45-degree folds, with minimal impact on signal integrity, really little or no impact on signal integrity.
Great. And I'm noticing one big difference in terms of form factor is this is kind of a round bundled cable.
Right.
This is a ribbon cable. What's the difference in terms of termination? Can you terminate the two in the same way?
Good question. There's some significant benefits in the cable assembly process for this type of construction. I've got a little prototype sample here of a ribbon terminated to a paddle card. And because our wires are fixed in a known position consistently, there's no extra jigs or fixtures required to position discrete pairs in the right order and to align them to the pads on the paddle card. If you design your paddle card to fit the ribbon, or we can design our ribbon to fit your paddle card, everything just lines up, and there's really minimal tooling required. Also, in terms of some of the other steps in the assembly process, foil stripping, a single foil stripping step, as opposed to stripping the foil individually on each differential pair.
Okay.
So another thing would be